Anyway, here we go. Let's get to this. Let's just go straight to this. This is from Gizmodo.com, and Gizmodo, right, is one of those sites that reports on stuff like this because, well, thank goodness for that, because somebody needs to. But as always, right, open source, meaning that open source with your ideas and thoughts and us having a conversation, but also in that all of my sources that I talk about, you'll find them in the links down below. So please check that out, and you'll be able to read exactly what I'm reading here. This is from Gizmodo. Scientists CRISPR'd tomatoes to make them full of vitamin D. Yeah, that's right, vitamin D. Right? These genetically modified tomatoes produce vitamin D when exposed to ultraviolet light. Right? Okay, this is fun. Right? This is fine. Here we go. This is straight from the article, straight from Gizmodo. And you'll see where I'm headed with this tonight in just a moment. The tomatoes of the future could help boost your levels of the sunshine vitamin. Researchers in the UK say they've developed genetically edited tomatoes that can produce high levels of vitamin D with just an hour of ultraviolet light exposure. These edited tomatoes would ideally help provide a rich and plant-based source of the essential nutrient, which is commonly lacking in much of the population. All right? Let's see. Would you like yours in a barrel, Mike? What? Anyway, I'm not sure what you mean. These edited tomatoes would ideally... Okay, just read that. The edited plant was created by researchers at the John Innes Centre in the UK. They use CRISPR technology. There's that word. That's what we're talking about tonight. CRISPR, C-R-I-S-P-R, and we'll get into exactly what that is. They used CRISPR technology to knock out an enzyme that limits the production of a compound naturally found in tomatoes called 7-dehydrocholesterol, 7-dehydrocholesterol, or of course, because we have to abbreviate these things and these words are huge, 7-DHC, or provitamin D3. Without the enzyme, the fruits and leaves of those tomatoes accumulated higher levels of 7-DHC. Okay, so this is where this starts, okay? And this doesn't sound very nefarious, does it? It's like, okay, we're gonna change the tomatoes and we're gonna make them better. Let's see. From inside the barrel? Am I inside? What is going on here? Well, I got audio problems. I hate audio problems. Hold on one sec. Let's see if we can figure something out here. Broadcasting from inside of a barrel. Is it really that bad? So that's off. This should be fine. What's going on there? Test. I'm not sure why there's a problem. Oh, there. There's the problem. Sorry about that, guys. It's fixed. Okay, back to the CRISPR miracles. Sorry about that. Thanks for letting me sound this is all my fault. Thanks for letting me know. Otherwise, I would have sounded like a knucklehead the entire time. Okay, so this is the thing, right? Back to this. This is fine because what are we doing, right? We're gene editing tomatoes, okay? And then we're gene editing the tomatoes to really have an easier way to just pump vitamin D into them. You put them in some ultraviolet light for an hour, and everything's fixed. Everything's fine, audio-wise, but also with the tomatoes, right? They've got a super boost of vitamin D, and people start eating this stuff, and then what, right? It's fine. Everybody needs a little bit more vitamin D in their diet, right? I mean, it's what we get from the sun and all the rest of that. And thanks for letting me know. I couldn't figure out what was wrong, but well, now I know. Okay, so in any case, right, this is where we're at. This is where this begins, just with this idea that you can genetically modify something and make it better, right? Make it better, which is fine. I mean, that's fine, right? Is it? I guess that's fine. Everybody wants, some fantastic I can't say it, nutrients. See, I'm just laughing at myself here because of the audio. Look, I tell you what, you take one day off and everything's out of sync, but that's okay. That's all right. Yeah, okay, so that's what's on my mind tonight. Okay, so here's the questions. We got some questions as we go. The first question is this. Have you heard of CRISPR? Do you know what this is? We're going to talk about it in depth tonight of what it actually is, okay? From a doctor from Yale who actually is able to say, look, this is exactly what it is. This is exactly what CRISPR means and stands for. This is exactly why they use it and what they're using it for. And also what the dangers are, because yes, that's right. Despite all of the bad press, or all the good press that CRISPR gets, it doesn't get a ton of bad press, or at least if it does, it gets, again, pushed down the news cycles or not pushed into them. And that's, again, part of the whole, right, the whole brainwash cycle. They want us to believe particular things. So the first question is, have you heard of CRISPR? Number two, the second question tonight is, Do you think CRISPR is a good idea? Do you think it's a good idea to not just, let's say, gene modify food, but also what about animals, and what about also people? Okay, that's the next question. Do you think it's a good idea? Number 3, what do you think some of the problems could be, even though, again, it's billed as like the next miracle thing, like the individuals that created the CRISPR technology won a Nobel Peace Prize, right, in science. And so it's like, okay, well, this must be really, really good, right? Because everything you read, all the articles you can pull up, you type CRISPR and go hit search the news, and you'll find like just gushing article after gushing article about vitamin D in the tomatoes and curing blindness and all kinds of stuff, right? You'll find all kinds of amazing press, right? But also, per usual, right? There's always another side to this story. There's always another side to this. Okay, so we've got this guy. All right, I'm going to play a couple clips from this guy so you can get exactly the idea of what's going on. But those are the questions tonight, right? Do you know what CRISPR is? Do you think that we should be using it for, let's say, plants and animals, and and then also humans? And then on top of that, do you think that what could go wrong? And of course, what could go right? Do you think that I guess these conversations have to be both ways, don't they? Like I said, I'm not a doom preacher, but I do like to highlight the back end of things, meaning that the stuff that doesn't get a ton of things, it doesn't get pressed to the front of the news cycle, right? Like you guys, you know me, like I always say, I have no special powers here. I just watch the news cycles very closely. And again, it's not always about what's in the news cycle, it's about what they leave out of news cycles. And that's the thing right there. That's the thing that always gets me. It makes me go, okay, interesting. So if you see everything positive about CRISPR, for instance, but you don't see anything typically negative pressed to the front of these cycles, because they want to catch your attention, right? You would expect if there was gloom and doom associated with the CRISPR technology, that there would be, right? If it bleeds, it leads, right? If it's ugly, I mean, people dying in a flood or an earthquake or a fire, that's like the first thing they show, or a shooting, or you know what it is, right? The news cycle presses that stuff to the front. But then, of course, if it's something to do negative with science, you don't see that a lot, do you? It kind of gets pressed to the back of the news cycles or bumped down in the search engines. And surely that's an accident, right? Surely that's an accident. That's not what this is about. We don't try and hide things in this society. Things are free and open. And anyway, love to hear your thoughts. Those are the questions as we begin tonight. We're starting with vitamin D and tomatoes. 702-957-1037. That's 702-957-1037. And there we go. Let's listen to this individual. This guy goes by the name of, let's see, what is his name? Greg Licolai, PRA Health Services, and from Yale Insights. He did an interview here. Again, links down in the description below if you want to check it out. But this is him describing exactly what CRISPR is, okay? Listen to this.
CRISPR is this fascinating, powerful technology. It's got a very clunky name. It's called clustered regularly interspaced short palindromic repeats. Now, what does that mean? So the name actually refers to the way it interacts with DNA. And it's a way to manipulate DNA, to edit DNA in a way that previously is much more powerful than previous methods, much simpler, much cheaper, and the important part is it's exceptionally precise. So as you probably know, our book of life is made of DNA. DNA itself is many millions of base pairs, which is like a language. And within that language, there are certain regions which code for genes, and those genes are incredibly important because.
Okay, well, the genes are incredibly important, of course, because, well, they're genes. There are genes that make up our, right, who we are, what we're going to become, right? From birth to death, our genes play an important role in many areas, right? Including the ability for genes to sort of self-select, be able to turn themselves on, based on, let's say, a period of famine or, things like this. Our bodies are pretty robust in those terms, meaning that we're adaptable, and we don't have to be, reborn in the sense that this lifetime we're just gonna, you're gonna have to go hungry, everybody dies, right? No, people adapt. People are able to do these things. Humans are extremely resilient, and it is in part because of our genes, because of our genetic makeup, right? Because of our DNA, and the way this all works together. Okay, I'm not a scientist. I just know human beings are amazing. That's what I know. Okay, bottom line, that's it. However, right, for every bit of amazing, we can also be just ugly and stupid and all the rest of that too. So you got to take both sides of that coin, right? Humanity can be a very good thing, but also, by the way, it cannot be. Okay, so that's the first thing, right? That's what CRISPR is. And we're talking about it tonight in the sense of, again, not just editing genes in terms of plants and animals. What about people? And of course, that's what's on my mind tonight. So there we go. So this is, again, an article from, let's see, this is from insights.yale.edu. Okay, and you can find this guy, Greg Licolai, is a lecturer at Yale School of Management, and of course the Center for Digital Health, a Chief Medical Information Officer, PRA Health Sciences, whatever the heck that means. And this was all the way back in 2018 when he was talking about this stuff. So things have changed since then, of course, and things do change. And some of these articles we're talking about recently are going to make you scratch your head and go, wait, what? I thought this was supposed to be the miracle thing, right? I thought CRISPR was supposed to be the miracle thing. And of course, back in 2018, Yale, right? Of course, Yale, we're supposed to, higher education is the bomb diggity, right? We're supposed to be like, yeah. Hey, Yale. Yale says, this guy's from Yale, and he says, hey. But the headline is CRISPR worth the risk? And that's the question tonight. That's what's on my mind. Do you think it is worth the risk? Do you think both sides of that same coin, again, not with just humanity or anything else, but the idea that CRISPR technology changing genes of things to, let's say, get desired results out of particular organisms, and once you start to put it like that, because, well, it starts to sound scary, doesn't it? Because organisms could be fruits and vegetables, right? Organisms could be animals. Organisms could also be people. And we've talked about in the past the idea of the CRISPR babies. We shout out to Daryl in New York out there, where we were talking about this last week or maybe a couple weeks ago, about everybody having the same baby, right? Because if they're buying the same CRISPR kit or whatever to get the exact same baby, well, maybe that's exactly, maybe. So anyway, I don't know. Look, so this is the individual, this is the guy, and this is what he's talking about. Let's go to clip number 2. This is exactly, one more thing real quick. He's got a lot to say about this because he's studied it. He's worked on this stuff. And listen to this. This is part 2 of, again, Greg Licolai from Yale on CRISPR action.
Those genes go on to make up everything about us. There's 40,000 proteins that become outputs of those genes, and they're involved in really our health, our well-being, and any defect in those genes becomes problematic in disease. So what was previously attempted with gene editing was to manipulate genetic information in blocks, basically in big pieces. It's kind of like trying to edit a book by only being able to rip out a page at a time and transfer a page at a time without really being able to control the actual words. The power of this technology, it literally comes down to the individual letters. So the precision is far better than anything that's happened before. And the excitement in the scientific community is being able to go in and very precisely make changes in DNA of actual genes that you can actually turn off bad genes, or you can potentially repair genes that have got mutations in them where the code is written incorrectly.
Ah, yes. Bad gene. You're not doing what you're supposed to be doing. So we're going to take this CRISPR and we're going to perform some miracles. And we're going to go turn the genes on and turn the genes off and make you the perfect person. All right?